units, 4 units, 4 units. So one thing is that all 4 sides are congruent. The other thing that makes it a square is that every angle, notice, is a right angle. And it has 4 right angles. All right, so number 2. What is the side length of each square? So the side length of each square, let's look at side length of square A. Okay, so square A, count it up. You have 1, 2, 3, 4 units. All right, let's talk about square B. Square B, if you count this out, that would be 3 units. Now, what is the perimeter of each square? Now, remember, perimeter, okay, is adding up all the sides. So side plus side plus side plus side, 4 sides. Or you can just know that there are 4 sides, so you can multiply 4 times the side. So let's do square A first. Square A, adding up all the sides, would be 4 times the length 4, which is 16. So square B, we're going to do the same thing. We're going to multiply 4 times 3, which would be 12 units. Okay, what is the area? Remember, area is going to be side times side. Sometimes we like to say side squared. So let's look at square A. So the length is 4, so it would be 4 times 4, which is 16. That would be units squared, because area is always squared. Square B would be 3 times 3, which is 9 units squared. And you can actually count. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes in that one. And there's 16 in this one. All right, so why are 16 and 9 called perfect squares? So 16 and 9 are called perfect squares. Well, that's because when you do 4 times 4, you get 16. When you do 3 times 3, you get 9. So that's really 4 squared and 3 squared. So these are perfect squares. All right, so let's use the geoboard to model each square and complete the table below. So I'm actually going to take you to a website that you're going to look, and we're going to fill in this chart below. So I'm going to show you what the website is, and I'll show you how to do it. I'd like you to try it on your own. And then when you're done with that, you can double check that your answers are the same as mine. I won't come back to this worksheet until after you've done everything. All right, so let me head to that website here. Yes, you're seeing crazy things on your screen, but here's the website. So take note of this. We're at apps.mathlearningcenter.org/geoboard. So go ahead and type that in. You're going to pause the video, type that in, and you can use this. Now, before you pause the video, I'm going to show you how to use this, and then you can try some on your own. All right, so if we have a side length of 5 units and we want to know the area and the perimeter. So what you're going to do is you're going to drag one of the rubber bands up, and it doesn't matter where you place it. We're going to make a square with side length of 5. So there's 3, 4, 5. You just kind of drag the rubber band down. I also want it to be 5 wide. So you just grab somewhere in the middle of the rubber band, count over 5 units. Once again, you're going to grab somewhere in the middle of the rubber band and make 5 units. So here's our square, 5 units by 5 units. Okay, so let's answer some questions, and this is on your paper with the area. So 5 units long means to find the area, you're doing 5 squared. So 5 squared would be 25 units squared. And you can count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So you have 25 squared units. That's where that comes from. And remember, just your units are always units squared. Now for perimeter, you're going to take the length of the outside of the shape. So count them up. Really, you're doing 4 times the length, which is 4 times 5, and you get 20 units when you're talking about a 5 unit square. Now, to clear it, you're going to go down to the bottom and you're just going to hit start over. It's going to ask you if you want to clear it and you just say yes. So then you move on to the next one, which is 8 units. So I'm going to drag a rubber band up. I'm going to make it 8 units long. So that's 4, 5, 6, 7, 8. I'm going to take it and go 8 units wide. So that's 1, 2, 3, 4, 5, 6, 7, 8. And then just drag it and make it a square. So here's my square. And then I'm going to answer the following questions with this length. All right. So go ahead and go to that website. I want you to fill in the rest of the chart. And then when you're done, just make sure that your answers are the same as what I have. Okay. So go ahead and do that right now. All right, so let's just make sure that we have the correct answers. Now, I don't have this done, so I'm just going to fill this in real quick for you. I didn't want you staring at the other screen. Okay, so just make sure as I'm writing that you have the same answers as I do. All right, so there's the answers to the bottom. We're making squares. These are the side lengths. These are the areas. These are the perimeters. All right, so a number is called a perfect square if it represents the area of a square whose side length is an integer. So which column above, in the chart above, contains perfect squares? So if I go back to this chart, which ones are the perfect squares? When you take a number and you find the area. Well, obviously the area is in the middle column. Okay, so those would be your perfect squares. So the area column. So if you go back and look at what the perfect squares are, that would be 25, 64, 49, 4, 9, 36, and then obviously x squared. So we have 4, 36, 49. I did not go in order there. Okay. I'm just going to write, though, that possibly not x squared. And the reason is because it depends on what x is. If x is not an integer, then that's not going to be a perfect square. So depending on what x is. If it's not an integer, it won't be a perfect square. All right, so let's look at exercise 2. Construct all the squares that are possible using your geoboard. Consider only squares with horizontal and vertical sides. Record the side lengths and corresponding areas in the table below in order from least to greatest. So what that means is we're going to start with the units. So 1 unit square, okay? What now? When you are doing a 1 unit square, to find the area, we're going to take 1 squared. 1 squared is 1. Okay, so the area would be 1 unit squared. Now, the square root of the area, that's the symbol that looks like this. So the area is 1. So the square root of 1, okay, is going to be 1 unit. And that's because the square root of 1, the perfect square, will be 1 unit long, or 1 unit. Because this number times itself will give you the 1. So let's go to the next number, 2 units. So to find the area, you do 2 squared, which is 4. So that's 4 units squared. Now, to find the square root of the area, remember the area is 4. Okay, the square root of 4 is going to be 2 units because 2 times 2 gives you that number 4. All right, so let's do 3 units. So 3 squared is the area, which would be 9. So 9 units squared. So take the square root of that, which is the square root of 9. Now, what number times itself gives you 9? That would be 3. All right, next one is 4 units. So 4 squared is the area, which is 16 units squared. Now take the square root of that area, 16. So what number times itself gives you 16? And that would be 4. All right, how about 5 units? That would be 5 squared, which is 25. So take the square root of 25. What number times itself gives you 25? And that would be 5. 6 units would be 6 squared, or 36. So the square root of 36, what number times itself gives you 36? That would be 6 units. All right, 7 units. So 7 squared is 49. So the square root of 49, what number times itself gives you 49? That would be 7. So 8 units would be 8 squared, which is 64. So take the square root of 64. What number times itself gives you 64? And that would be 8. 9 units. 9 squared is 81. So the square root of 81 is 9. Last one is 10 units. So 10 squared is 100, which is 100 squared, or 100 units squared. So the square root of 100 would be 10. All right, last part. If you know the side length of a square, how would you find its area without a geoboard? So if we know that area is side squared, okay, how would you find the area? Well, you know the side length, you just would square it. How could you find the side length without a geoboard if you know the area? Well, the side length, if you look up at our chart above, can be found using the square root of whatever the area is. So what is the relationship between the side length of a square and the square root of its area? Well, if the side lengths are integers, then the area is the perfect square. If the square root of the area is a square, then its perfect square is a positive integer. Okay, so if the side length, if they are integers, then the area is a perfect square. So just to sum this all up, these are all going to be perfect squares when you're talking about integer side lengths. All right, go ahead and try that problem set for homework tonight. We will go over it in class tomorrow.